Hello, everyone, and welcome back to the Science Society podcast. I know that we've kind of disappeared for like 4 or 5 months after our last April Fool's Day episode, but today we're back to talk about more science stuff. Today we have a new speaker with us.
Hello everyone, my name is Dan. I am the Public Relation of Science Society Club. Nice to meet you all.
And obviously, I'm the recurring character, Nawat, who shows up too much. But anyway, today we're going to talk about something that we're passionate about, right?
Yeah.
So both of us are from computer science. So we thought that maybe we should talk about how everything in computer science, or like at least modern computer science, started. So today we're going to be looking at the life, inventions, and impacts of Alan Turing, the father of computer science.
Yeah, so let's have a look of who he is a little bit better before we know more in depth about him. So first off, Alan Matheson Turing was an English mathematician, computer scientist, cryptanalyst, philosopher, and many more things. But he was highly influential in the development of theoretical computer science. He invented the Turing machine, which can be considered a general-purpose computer. He is widely considered to be father of theoretical computer science and artificial intelligence. So, Turing born in Maida Vale, a residential district in London, and raised in southern England. As you expect from a genius, his education background is quite special. So, he graduated at King's College and from the department of the degree in mathematics at the University of Cambridge, of course. And he got a PhD, which is something that I hope I got someday.
Wow, Dr.
Yeah.
Dan. Will you become Professor Dan?
Yeah, maybe someday. Okay, he obtained his PhD from Department of Mathematics at Princeton University. And while he was teaching at University of Cambridge, he invented the Turing machine. What is Turing machine, you ask? So Turing machine is a machine that manipulates symbols of zeros and ones on a tape according to a defined table of rules. And despite its simplicity, it can do every algorithm that the modern computer can do. It's like the all-father of our modern computer that we use today.
The father of computer.
Yeah.
And the fact that he did mathematics kind of makes me confused. Because I think a lot of people tend to think computer science is like software engineering, but it's actually math. It's always has been
Yeah, I mean, behind like algorithms and calculators, there's always maths involved.
my favorite subject.
Yep. And let's look at his achievements a little bit. So during the Second World War, he created the Bombay method. It's an electromechanical machine that could find settings for the Enigma machine. It helps ending the war by 2 years early. And although he accomplished so many, Turing was never fully recognized in Britain during his lifetime because much of his work was covered by the Official Secrets Act. Even a genius like Turing has love. I mean, what is life without love, right?
Oh my god.
Yeah. And
love and life.
yep.
Love life.
So, when Turing was 13, he enrolled in a Sherborne school, and it was there that he met his first love. He's a boy named Christopher Morcom. They start as a friend, and their relationship grows more and more closer. Morcom even invited Turing to his house to meet his mom, Mrs. Morcom, and unfortunately, reality is harsh. In February 1930, he died due to bovine tuberculosis, an illness which he contracted a year earlier from tainted milk. But it's like two-edged sword. I mean, although his death is sad, but it also inspired Turing to want to understand about the mind. So he's like immersed himself in related to work of biology, metaphysics, philosophy, and mathematical logic and quantum mechanics. And he also loves tingling with mechanical parts, something that CS people
We don't
might
really do.
love. Or,
Really?
I don't know.
I think most of us just prefer to type on a keyboard.
Yeah,
And like make sure that things run in a magical world of the software. But,
yeah.
Yep.
At least we should touch something, I think.
Touch grass.
Touch grass.
All right.
And it is natural for people like him, tinkling with machines and have a lot of knowledge about mind. So he think of a machine which the process could be modeled and predicted with mathematical logic. So after we know about his first love, about Christopher Morcom, now we will look into like a little bit more about his love life, about his engagement and homosexuality. So Alan Turing was once engaged with a woman named John Clark. However, since Alan Turing was homosexual, they did not get married. And because of his homosexuality, he got prosecuted at the time. Homosexual is illegal. And he had two choices. The first one is that he go to jail, and the second one is that he go through the hormone treatment, which is inhuman because, by today's standards, because what he did was to put testosterone into his body. They believe that it would turn him from gay to straight.
Which probably didn't work and definitely destroyed his body.
Yeah.
Yeah.
And later, and at the 7th June 1954, Alan Turing met his death because of cyanide poisoning. It is still argued that why or what happened. We still don't know until the present day what happened. Like, is it suicide? Is it because of accident? Because of his research? But yeah, in the end, he gone.
Yeah.
But his legacy still lives on. So we all computer science students know an annual award that we give out every year called, I'll let you guys guess. 3, 2, 1. Is Turing Award. Of course, they tend to put the name of the person above every award.
Yeah.
And
would you like a Turing Award? You're gonna spend like 50 years working on it?
I hope.
All right.
Someday.
Let's go.
And he appears on the current banknote of England, the 50 euro note, which was released on 23rd June of 2021, quite recently.
Yeah, it's time to go to the UK and get myself some 50-pound notes and put it in a frame it, and then pray to it every time I do a CS homework.
Yeah,
like,
pray
please
to our father of computer science,
bless me.
run my code.
Oh no, it doesn't hold.
Oh. And Queen Elizabeth II granted a posthumous pardon in 2013, because they prosecute him to be criminal. And the term Alan Turing law is now used informally to refer to 2017 law in United Kingdom that retroactively pardon men caution for convict.
Still too late.
Yeah, a little bit too late, but under historical legislation that outlaw homosexual act, so he became a symbol against homosexuality, like
Discrimination.
yeah,
against-
discrimination. And that's why we should not discriminate anyone because like his sexual preference. Alan Turing, even though he's gay, he is a genius person. He have a lot of intellect.
Yeah.
And he do a lot of research, and he had done so many things in his career, and we should know some of them.
All right, so now we can talk about the fun stuff, at least to me. So Alan Turing is known as a very genius man. He's very, very smart about a lot of things, mathematics and logic and cryptanalysis and a lot of things. But most of this part is going to be introductory stuff because everything is very abstract and complicated and it's going to take like 3 hours if we're going to talk about everything. So
Yeah.
we're going to shorten it down to fit like a 20-minute episode podcast.
We speed run this thing.
Yep, we're going to speed run Alan Turing's discoveries and his career and research. Anyway, if you're interested, we will leave links in the description for where you can learn more about different things that we're going to cover. So let's get right into it. The first one is called actually I'm going to use Google Translate to read that for me because I don't want to piss off any German people.
Entscheidungsproblem.
Yeah.
Anyway, what it is basically a problem about decision problems. So it's a challenge posed by David Hilbert and Wilhelm Ackermann in 1928. The word itself means decision problem. So decision problem is basically problems that the answers are either yes or no. So it's like, are you happy in CS?
Yeah, I cannot say it's not a yes.
It's either yes or no then.
Yes, of course.
Okay, are you happy in SSC?
Yep.
Alright, cool. So the problem or the challenge itself basically asks if there exists a way to solve every single decision problem. So imagine you have like 1 million decision problem. You want a general step and a general algorithm to solve it. And basically Alan Turing and Alonzo Church, they show that no, it is not possible. It's incomplete. Basically, they're saying that logic is incomplete. Human logic is incomplete. And they did this by Turing using the Turing machine and the halting problem, and Alonzo Church using lambda calculus. So now let's talk a little bit about the halting problem. Do you know what a halting problem is?
Maybe it's problem that halting.
No. Eventually you will in algorithms. Look forward to that part.
Okay.
Anyway, halting problem is a problem that if you're given a computer program and its input, it determines whether or not the program will stop running or not. So it becomes a decision problem because it either yes, it will halt. So after a finite set of steps, it will stop running and then it will spit out an answer, or no, it will not halt, so it will be running forever for infinite loop, whatever. And we want to note that the program has to be run on a Turing machine, which is basically a modern day computer. And yeah, as we said, it is an example of a logic problem or a decision problem because it's like yes or no. And in order to use the halting problem to kind of prove that our logic is incomplete, we're going to explain what the halting problem is by itself. So we start by creating a machine that checks whether or not algorithms will terminate or not, or computers will terminate or not. We're going to call it H. And then to show that it's impossible for computers to solve the halting problem, Turing put H into a bigger machine. We're going to call it big.
Okay, big machine.
Yep, it's going to be big now. So this machine will loop forever if H says that yes, a program will halt. So if H says yes, it will halt, B will run forever. And if H says that it will not halt, B will halt.
Okay.
Make sense?
Makes sense.
Confusing, right? It gets worse. It gets worse. Just like every CS class ever, it gets worse as time goes on. We definitely love our majors, by the way.
Yeah.
Anyway, then after we have B and H, we feed B into itself. So basically, we can think of B as an algorithm, and then we put B into itself, because technically B would have to take algorithm and an input because it has to feed into H inside of it. So basically, we feed B into itself, and this creates a contradiction because if B terminates, if B halts, then H inside of it will say that it halts, but then because like B's actual behavior depends on H's behavior, H's answer. So if H says that B halts, it runs forever.
Yeah.
And obviously it works the other way around. So if B doesn't halt inside of inside of itself,
It can contradict each
then
other.
then H will say that it doesn't hold, and then B will hold. So that's a contradiction. It's a technique that we learn in discrete math, everyone's favorite math subject. Anyway, this basically contradicts itself. It's a contradiction. It's a paradox. Basically, it's impossible to solve this decision problem because there exists an input that will break it, basically. And basically, it says that not all decision problems are solvable, and therefore proves that our logic is incomplete, basically. Confused yet?
A little bit.
Good. You're now living my life when I was taking algorithms.
Yeah.
This is like algorithm speedrun.
Yeah.
You sound very enthusiastic. I can feel it in your voice that you're looking forward to taking that course.
Of course.
Anyway, so the next achievement that he did after proving that our logic is incomplete is to decrypt the Enigma machine. So I think Danny kind of covered it a little bit. Enigma basically is a machine that encrypts messages, and it's used by the German army during World War II. It basically you can configure it to encrypt different messages in different ways. So it basically replaces each letter in the language with another one. And these settings change daily, which is why it takes so long to decrypt the Enigma machine, because it basically when you decrypt one message in a day and you get the configuration.
Yeah, the rules change.
Yeah, the rules change, and then your work for the past day is useless and you have to restart all over again. And obviously, if you're interested, you can watch the Imitation Game, the movie. It basically talks about Alan Turing's life in Bletchley's Park, which is where he was decrypting Enigma. And then now let's talk about how it was decrypted. So basically, it's the Turing-Welchman Bombay machine, or also known as Agnes Day or Agnes. It's a Bombay machine that searches for the configuration for each day of the Enigma machine that the German is using. And it basically works by comparing the patterns that is seen in the text, in the encrypted message, and a portion of something that is already known. So I think that in the movie, it says that there's a portion of every message that is basically the same thing, and they just compare the pattern to that part, and then they can decrypt the whole message. And the most important thing that I want to point out in this part, because it's like really interesting to me, is that Enigma broke because it works too perfectly. It's basically whatever configuration you put in, it will always produce the same result.
Mm-hmm.
So breaking it is just a matter of reverse engineering it, and eventually, and we did. And not we, Turing did.
Turing
and his team at Bletchley's Park.
Everyone confused until Turing walked into the room.
Yep. It basically shortened World War II by 2 years just by decrypting the configuration for each day. And the UK, at least at the time, decided to call him a criminal because he was gay, even though he saved countless lives and ended a major war conflict. So good job, UK.
Yeah.
Yep.
Good job.
This is why our logic is not complete. Anyway, the last thing that we want to talk about is artificial intelligence, because it's like the big thing in
computer science.
Yep, it's like the only thing people talk about.
It's what you guys think, right? Computer science, artificial intelligence, AI, do everything.
Machine learning.
Deep learning, machine learning.
Every tech buzzword ever. But we're going to go back a little bit in what artificial intelligence is. So his work on artificial intelligence, or on AI, is basically developing the Turing test. So yeah, it's basically checking if a machine has human-like intelligence or not. So to play this test, it's also called the imitation game. Like it's alias. Like before it became the Turing test, I think it was called imitation game, and I think that's kind of where
the movie.
Yep, probably where the movie name come from. It's a really good movie, by the way. You should go watch it. I think it's on Netflix if you use VPN, or you can find it on Amazon Prime or some shady websites. Yeah. anyway, to play the imitation game, I'm going to use that name now. You have three entities. You have the evaluating human. I'm going to call him E. You have a conversing human, which I'm going to call it H. And we have a conversing machine, which I'm going to call it M. So M is designed to generate human-like responses. Basically, it's like text. And E is allowed to talk to H and M. And then after a certain period of time, they will determine which is the human and which is the machine. And if M successfully convinces E that it is the human, then it passes the test, or like it wins. And one of the first programs that we believe that have passed the Turing test is called ELIZA. It's created by Joseph Weizenbaum, and I'm definitely going to get killed by mispronouncing another word. But it was created by looking for keywords in E's response. So basically, when you tell it something, it's going to look for a keyword, and then it's going to look up in its database of responses, and then it's going to spit out something, or like it's going to transform that keyword into a response. And if it cannot find a keyword, then it's just going to repeat something that I already said. And basically, it did the test, and apparently it convinced a bunch of people, but this is sort of controversial because some people think that, the people who were doing the test, the evaluators for that test, were kind of naive. Like, they didn't even know that they might be talking to a computer, so they just assumed that they were talking to humans. So maybe it's not the most accurate thing ever. So that should be it for the Turing test, or the imitation game, whichever one you feel like calling it. And that should be it for his career and research. What do you think?
I think knowing our
Origin.
quote unquote father of computer science, since I am a computer science student myself, I think it's very inspiring that his accomplishment did so many things, and the very machine that he invented can do everything that we do now.
It's basically the basis for the modern computer, right?
Yeah.
Yep. So anyway, that should be it for this episode. If you're an MUIC student, you can go to the description and find a Google form. When you complete it, you will be able to get 80 hours. And if you're just passing by from a random place from YouTube, thank you for listening, and hello. How did you come here? Let us know in the comments below. And if there's anything that you learned from this episode of the podcast, it's don't be like the UK back when Alan Turing was alive, and don't discriminate against people just because they're different. Because we're all different, but we can all be intellectual and good people. And that's it for this episode. Hopefully, we will see you next time if the AI overlord don't take over. Goodbye.